Welcome back, everyone. Moving on to the next video. So another word problem dealing with linear systems. And we have a scenario here, and then there's actually three cases for the same scenario. So it's like three different types of questions combined into one. So let's say a school concert sold $6 child tickets and then $11 adult tickets. How many of each type of ticket was sold in the scenarios below? So the first scenario, there was 92 tickets sold in total for $762. Number two, there were 8 more adult tickets sold than 1/3 of the amount of child tickets sold. And the total was $523. And then number three, a total of $632 was made, where 248 more was made from adult tickets versus child tickets. So notice how we could take a scenario like this, which is a popular type of linear system word problem, and then we can ask a question in many different formats. So starting with the first one, actually before I get into actually dealing with the specific scenario, I kind of want to generally talk about how we're going to set all of these up. So notice that we have child tickets and then adult tickets. So what we're going to do, we're solving for the number of tickets for each scenario. Right? How many of each type of ticket was sold in each of the scenarios? So I'm going to let the number of child tickets be X, and then I'm going to let the number of adult tickets be Y. Those are the variables we're going to solve for. Now, we got variables here. Notice that we can also, with the information, create expressions for the amount of money that's made from each type of ticket. So this would be the, let's just call it the amount of money made from the sales. So in terms of the child tickets, if we sold X number of tickets and each of them is $6, then the total amount of money made from the child tickets would be 6X. And then there's Y number of adult tickets, each cost $11. We would just multiply that by 11, like that. So this would be the total amount of money made from the child tickets, the total amount of money made from the adult tickets, while these are just the number of tickets. And so with that, we can create expressions for all the scenarios. So the first scenario says there were 92 tickets sold in total. So that means X plus Y would be 92. And then the total was 762. So both of these totals would add up to $762. So notice this first equation is in terms of the number of tickets. This second equation is in terms of the actual dollar amounts. And now we got two equations and two unknowns. So this one I'm actually going to solve with, let's do elimination with this one. So I'm going to put the second equation up top here. And we can get rid of the x's or y's. I'm going to choose to get rid of the x's. So I'm going to take all of this and multiply it by 6, right? To get the x's the same. So 6 times x is 6x. 6 times y is 6y. And then 6 times 92, that would give us 552, like that. And now notice we could subtract both of these from each other to get rid of the x's. So we'll have 6x minus 6x, that's just 0. 11y minus 6y would give us 5y. And then 762 minus 552 is 210. Then we got the equal sign over here. Now we subtracted these because they're the same sign, but if this was like a negative 6x, then we would be adding these, because then that would net out to 0, and then we would have 17y, and then we'd have whatever number right there. But because they were the same sign, then we're subtracting this from that. So we end up with 5y equals 210. Divide both sides by 5, so y would be 42, like that. And now that we have the y, very easy to get the x. I would use that first equation that we had. I feel like that's the most simple one. Plug in 42 for y, so x plus 42 equals 92. x would be 50. And then you could also check your solutions. You could take these, plug it into both equations, make sure left side is equal to right side. So the number of child tickets sold was 50, and then the number of adult tickets sold was 42. Moving on to the second scenario. So there were 8 more adult tickets sold than 1/3 of the amount of child tickets sold, and then the total for the sales was $523. So notice I still have that chart that I wrote out at the beginning of the question. We're going to use it for all the scenarios. So we're told the total was 523. So very easy to create an expression for that. It's just these two equals $523. Remember, this is the dollar amounts here, and this is the number of tickets. This second equation is going to be a little bit more difficult. You got to read it carefully. So there were 8 more adult tickets sold than 1/3 of the amount of child tickets sold. So with these kind of sentences, a lot of times I like to go backwards. So 1/3 of the amount of child tickets sold. So we would take the number of tickets sold for children, multiply that by 1/3. And there were 8 more than that for the adult tickets. All right, so one more time, there were 8 more adult tickets sold than 1/3 of the amount of child tickets sold. So 1/3 of the child tickets sold plus 8 gives us the number of adult tickets sold. And so here, 2 equations, 2 unknowns. So different ways we can go about this. What I'm going to do is I'm going to actually multiply everything by 3, because we could take this and we can plug it in here, but then 1/3 times 11, when we distribute that 11 inside the bracket, we're still going to be working with fractions. So what I'm going to do is I'm actually going to take everything here, I'm going to multiply it by 3, and then I'm going to isolate for the x. Just get rid of the fractions. You don't have to do it this way. There's different ways you can go about this. Whatever way you do it, just make sure you're getting the same answers that I do at the end. So 3 times 1/3, that gives us 1, which is just x, plus 24 equals 3y. And now notice x equals 3y minus 24. And now notice when I take this and plug it in here, we're not going to be dealing with any more fractions. So that's what I'm going to do. So I'm going to have 6 bracket 3y minus 24, plus 11y equals 523, like that. Multiply these, distribute the 6 inside the bracket. Bring the 144 over, the negative 144, 523 plus 144 gives us 667. 18y plus 11y gives us 29y, like that. And then we could divide both sides by 29. Y would end up being 23, like that. And then what we can do to find the x, we could actually plug it in here. So we would have x equals 3 times 23 minus 24, like that. Which this would be what? 69 minus 24, which would give us 45. So those are the 2 answers. And then you could check them. You could take this, plug it in here, should equal 523. And then let's test out the sentence. So there were 8 more adult tickets sold than 1/3 of the amount of child tickets sold. So the amount of child tickets sold was 45. 1/3 of that is 15. And then if we add 8 to that, 15 plus 8 would indeed give us 23. All right, so everything checks out. Those are the 2 solutions. And then finally, moving on to the third scenario. So a total of $632 was made, where 248 more was made from adult tickets versus child tickets. So still using that same chart here. And in this specific scenario, actually, we're just going to be using this row. Because notice here, we're not given any information about the number of tickets. Everything is all in terms of dollar amounts. So the two equations we could set up, a total of 632 was made, so basically 6x plus 11y has to equal 632. And then it says 248 more was made from adult tickets versus child tickets. So we made more money here, and the difference between them is the 248. So the other equation we could set up is 11y minus 6x equals 248, like that. Does that make sense? $248 more was made from adult tickets versus child tickets. So the difference between those, with the adult tickets being more, so it would have to be here. You can't say 6x minus 11y. That would imply there's more money made with the child tickets. You have to put the 11y here. So 11y minus 6x would be 248. And then from here, what we can do, notice that we actually have the same coefficients. So I'm going to take this, rewrite it, and then I'm going to take this, I'm going to rearrange it, and I'm going to say negative 6x plus 11y equals 248. I just put the negative 6x in front like that. And the reason why is now these are in line in terms of the variables. And then what we can do here, we could either get rid of the y's or get rid of the x's. I'm going to get rid of the x's. So what I'm going to do is I'm going to add both of these because they're the opposite sign. So 6x plus negative 6x would give us 0. 11y plus 11y would give us 22y. 632 plus 248 would give us 880. Divide both sides by 22, and y would be 40. So that's the amount of adult tickets sold, the number of tickets sold. And then what we could do is, let's plug it into one of these. So let's plug it into this one. We'll have 11 times 40 minus 6x equals 248, like that. And so here we would end up with 440 minus 6x equals 248. We can bring this over, so we'll have 440 minus 248, which would give us 192, and then the negative 6x comes over, that would give us positive 6x, like that. Right? 440 minus 248 is 192, divide both sides by 6, x would end up being 32. So those are the two solutions for the third scenario. So the number of child tickets sold was 32, the number of adult tickets sold was 40.